Okay, my dear beloved students of HSC, today we're going to discuss about vector from physics first paper. In my video series, you have seen we have discussed about addition of vectors and the resolution of vectors. Now, in a real example, we will see how these two theories, these two knowledge can we use. Let us have a look. So, we will discuss on boat and river velocity related problems. For this, let us consider the velocity of a boat in steady river is p meter per second, and one day the velocity of river current is q. Okay, let us alter, because velocity of boat is q meter per second, and to write down this is p meter per second. No problem there. And let us consider the boat is moving, the boat is crossing the river. We will discuss in today's class all the topics related boat river velocity problems. So if you attend the class with your attention, I do believe all sort of problems related to these things will be solved. So be attentive, please. So the boat is crossing the river. It's crossing the river at an angle of alpha with the direction of current. With the direction of current. Okay? Fine. Now I want to calculate. Number one, I want to calculate the actual velocity of boat. I want to calculate the actual velocity of the boat. So let's figure out the problem. Let us consider this is the river. And this is the river velocity. It is p meter per second. And for example, you are crossing the boat. You are crossing with the boat at a velocity of q meter per second. So what is happening? Look, Phil, the boat river will give you a pusher, each and every point. So you will be diverted from your direction. What will happen? You will be diverted from your direction. So actually, you will go. So your direction will move like this, in a way like this. So actually, what will happen? On this point, two vectors are acting simultaneously. Two vectors. One vector is the velocity of current, and another vector is the velocity of boat. When these two vectors act on the same point, the boat will go in the resultant direction. It will go in the resultant direction. Okay? So let us consider they are moving at an angle of alpha. They are moving at an angle of alpha. So they will go in the direction of resultant direction. So we know the resultant direction R is equals to square root of P square plus Q square plus 2PQ cos alpha. 2PQ cos alpha. Okay? Right? This is the actual velocity of the boat. And which direction he is going? He is going at an angle of theta. He is going at an angle of theta. So I can calculate the theta as well. So tan theta will be equals to Q sin alpha divided by P plus Q cos alpha. Okay, dear students. So now you can calculate what's the actual velocity. It will go in this direction. It will go in this direction. Please complete the parallelogram. This is the completion of the parallelogram, and this is the diagonal. So it will go in the direction of the diagonal, and the length of the diagonal will be calculated by this formula, and the angle theta will be calculated by the second formula. So dear students, now you can easily calculate the actual velocity of the boat by using these two formulas. Okay, now if the boatman wants to cross the river strait, second one, if number two, if the boatman wants to cross the river, straight. Then what he should do? Okay, so let's redraw again. This is the direction of river current. This one is P meter per second. Okay, look, if he start moving this direction, the river current is bounding him to go in this direction. So what he should do? He will go in that direction, in the opposite direction, like this, so that he can go straight. Okay, he can go straight. Okay? So, if he wants to go straight, I can say that consider it should go with an angle of alpha. He should go with an angle of alpha. So I have to calculate the alpha. And one thing, the velocity is km per second. Okay? So one thing is this, if he should go straight, that is, if it is the resultant, it is the actual direction by which he will go, right? So in this direction actually he will go, that means actually he is making an angle of 90 degree. He is making an angle of 90 degree with the river current. He is making an angle of 90 degree with river current. So you know the angle between resultant and P vector we denote it by theta. So theta is equals to 90 degree here. So I have to calculate alpha. So which formula I can choose? I can choose tan theta equals to Q sin alpha P plus Q cos alpha. Okay, so tan theta equals to, I can put that theta is equals to 90 degree. Theta equals to 90 degree, and we know that tan theta is equal to sin 90 by cos 90. I can write it by sin 90 divided by cos 90. And we know sin 90 is equals to 1 and cos 90 is equals to 0. So 1 by 0 is equals to this one. Okay, so by simplification, what I can write? I can write that P plus Q cos alpha equals to 0. Ultimately I have got, that means alpha is equals to cos inverse minus P by Q. So I should say that at alpha angle, he should go to cross the river straight. So these values, numerical values, for example 2, 3, 4, 5, 6, this type of values will be given. And one very important thing, look, if the question comes like this, for example, the board velocity is 4 and this velocity is 2. This velocity is 2. That means the velocity of boat is double of the velocity of river. The velocity of boat is, if the velocity of boat is the double of the velocity of river, then what will happen? What will they do? The velocity of P is 2 and this one is 4. That means half. That means at that case alpha will be 120 degree. So I can say that if the velocity of boat be the double of velocity of current, then easily you can say that to move straight, the angle will always be 120 degree. 120 degree. Okay, next time I will upload another video that how can I go, or how can a boatman cross the river with minimum distance. And at that video I will upload another thing, how can you cross the river with minimum time. So wait for the video and practice this sort of mathematics. Thank you very much.